This is 2014 sample, and we're on question 12. Okay, so it is solve the inequality. Now it's minus 2 less than 5x plus 3, so we write down minus 2 less than 5x plus 3, and then the other side is going to be 5x plus 3 is less than or equal to 18. X and element R. X and element R means minus numbers, positive numbers, decimals and fractions are included. So when we shade in a number line at the end, we usually shade in the line, okay? So what we're going to do here is we're going to do a switch first and foremost. So we're going to say 5x plus 3 is bigger than minus 2. It's the same thing as saying 5 is greater than 4, therefore 4 is less than 5. We don't have to multiply by minus or anything, that just got to change it around. Next thing we're going to do is bring across 3, and what we're going to get is 5x is greater than minus 2 minus 3. Then we're going to get 5x is greater than minus 5. Divide across by 5, and we get x is greater than or equal to minus 1. On this one here we're going to bring over 3, it becomes a minus 3, and we're going to get 5x is less than or equal to 15. And then x is less than or equal to 5. So it's all the numbers between minus 1 and 5. Now graph your solution on the number line below. Because it's not greater than or equal to 1, the number 1 is not included. So a hollow circle indicates that it's not included, while 5 is included, and a full filled in circle indicates that it's included. It's all the numbers in between here. So what we're doing is we're just going to shade in all the numbers in between these two numbers, and this is the solution set we require. Neve is in a clothes shop and has a voucher in which she must use. The voucher gives €10 reduction when more than €35 is spent. She also has €50 cash. Write down an equation next to show the range of money she could spend in the shop. Okay, well, she has to spend more than €35 to get the €10 reduction. So if she spends €45, that €45 minus 10 will give her a €35 will be the cost, okay? So the minimum she needs to spend is €35. So when you think about it, it's €35 she could spend in the shop, okay? So we're talking about how much can she spend in the shop. Well, she could spend, she has to use the voucher. She must use the voucher. Well, this means that it's going to be €35 is the minimum she's allowed to spend, and she can spend up to a maximum of 50. Now, you got to remember is that if she's actually spending €35, the price range of the articles she could buy could be €45 because she's getting the €10 discount. So that's going to be 45 all the way up to 60, because 10 more than 50 is 60, and she's still getting that €10 discount. Okay, so that's the answer to that question. Next one, question 13. A rectangular site with one side facing a road. Here's the road here, just shading in red quickly. Okay. Which does not require fencing is L meters in length. So the part that doesn't require fencing is L meters long. Okay, the sides perpendicular to the road are X meters in length. So you can see this here is X meters in length. The sides, the length of fence that will be used in closing the rest of the site is 140 meters. So if I was to use this as green wire that I'm going to send around the fence, these three lines added together equals 140. So we call this Y. So Y plus X plus another X is 140. Bring the two X's over to your side and they become minus 2X. So Y equals 140 minus 2X. So what we have here is this length here is 140 minus 2x. Write an expression in terms of x for the length L of the side facing the road. Well, the side facing the road is the same length as this side that needs the fencing because it's a rectangle basically, right? So it's going to be 140 minus 2x. Show that the area of the site in meters squared is minus 2x squared plus 140x. Well, length, area equals length multiplied by width. So we have width and our length. We're going to multiply them by each other. So what we're going to get is x multiplied by 140 minus 2x. Multiply in, and we get 140x minus 2x squared, which is the same thing as minus 2x squared plus 140x. So that's proven. Okay. Now, let f be the function f of x equals minus 2x squared plus 140x. Okay. And what it's looking to do is it's looking for us to evaluate f of x. Now remember, f of x is the area, because the area of the garden, or of the rectangular site, is the blue area here, and it's gotten by this formula here, or calculated by this formula here. So basically the area equals this. The output is area and the input is what is the length of the fence. So what they want us to find out is what is basically f of 0, f of 10, f of 20, f of 30, f40, f50, f60 and f70. Basically, what is the area of the grounds when there's no length of 10, length of 20, length of 30, length of 40, length of 50, length of 60, length of 70. So let's see what happens here. Okay. So what we got to do is we got to write down minus 2 times 0 squared plus 140 times 0 minus 2 times 10 squared plus 140 times 10 minus 2 times 20 squared plus 140 times 20 minus 2 times 30 squared plus 140 times 30 minus 2 bracket 40 squared plus 140 times 40 and minus 2 times 50 squared plus 140 times 50 and minus 2 times 60 squared plus 140 times 60, and finally minus 2 times 70 squared plus 140 times 70. Okay, now these are all the workings. So what we're going to do is going to use the calculator here, and what we're going to do is go into mode. We're going to put into the table function. We're going to write down this table function here: minus 2 alpha x squared plus 140x. The start is at 0, the end is 70, and it wants you to go up in steps of 10. And what we have here is our numbers, okay? So we're going to get 0, 1200, 0, 1200, okay, 2000, 2400 twice, 2400 twice, okay, and then we're going to get 1000, 2000, 1200 and 0. And 0. Okay, so these are our functions here. Okay, now what we got to do next is we got to draw the area. Now we would have done this part on the rough work part, or do the graph on another part of the book. Okay, so what we're just going to do is just going to write down the points: 0, 0, 10, 1200, 20, 2000, 30, 2400, 40, 2400, 50, 52,000, 60, 1,200, and 70, and 0. Okay, so now we're going to go about drawing this. Okay, now to draw this, what I'm going to do is I'm going to need 24 blocks on the y-axis. Okay, because y min is 0 and y max is 2,400. Okay, so that's y min and y max. So what we're going to do is we're going to get our graph here, 24 blocks down hopefully, and each of the 3 blocks, every 3 blocks is going to be worth 300. So see how this works out. 300, 600, 900, 1,200, 1,500, 1,800. Now you can see I haven't got enough space. Okay, so what I'm going to have to do here is I'm going to have to move the full graph down. Okay, so you have to make a call on this as in how much space do you need. Okay, so we're just going to move it all the way down if possible. Okay, so there we go. Now we should have enough space. Okay, so we're going to extend this graph upwards. Okay, so we're going to go for 2,100, 2,400, and we can see about how far we need to go up down. Okay, so we're going to draw this graph, and when we draw this graph we have we have to go across in tens, so we might make each one worth 1, so we go 10, 20, 30, 40, 50, 60, 70. So each set of 3 is worth 1 block. Okay, so this is x, and this here on the y-axis is f of x, or area. Okay, so we're going to have 0, 0 is our first one, and then the next one is going to be 10, 200, or sorry, 10, 1,200, which is here. Then we're going to have 22,000. Now 2,000 is located here. And then we're going to have 30, 2,400. And then we're going to have another 2,400 here. And then we're going to have 2,000 here. And then we're going to have 62, 1,200. And then finally 70, 0. Now, the trick here is you're not to go straight across. Just to be a bit of a loop in the middle to get the maximum point. Now the maximum point occurs at x equals 35, but sometimes it's very difficult to know how far we need to go up. So what we can do to figure that out is we can figure out what is the input, what is the output when the input is 35. So what I can do here is go back to my calculator, just keep this the way it was, and just do start of 30, end of 40, step 5, and what I got here was the point 35. 35 is 2,450. That's basically all I have to do. It's the same thing as putting in minus 2 times 35 squared plus 140 times 35. We'll basically get 2,450. Okay, so that's what we're doing there. So what we can say here, okay, 2,450. Well, this is 2,500 is here. Oh, sorry, that's not 2,500. That's 2,700. Okay, because it goes up in 3. So 2,500 is here. 2,450 is just going to be exactly halfway. So this is the point that we just calculated there. So we're going to draw them all together and get our graph. Now Just make sure at the very top you have to go through all the points. Okay, so make sure you have a rubber on hand, just in case it's not perfect. Basically more or less it there. Okay, now find the maximum possible area for this site. Well, it says use your graph. Okay, so we already know it's going to be 2,450, but you'd probably just do it by eye. Just go up and down, then do it by eye. But sure, look, we know the proper answer, so we might as well use it. 2,450. Now it says find the area of the site. The area of the site is f of x. The area of the site when the road frontage is 30 meters long. 30 meters long. The road frontage is 140 minus 2x. So this means 140 minus 2x equals 30. This means bring 2x over one side, 30 over the other side, and we're going to get 140 minus 30 equals 2x. And this means that 2x equals 110. X equals 55 meters. Okay, so when x equals 55 meters, find out the area. So I'm looking for f of 55, or when x equals 55, find f of x. So what we're going to do is we're going to go to 55. It's located here, and we're going to go up and across. And that will be just under 1,700, so go about 1,690. So the answer for this one is 1,690 meters squared. You could also write in x equals 55, do what you did here earlier, just reuse the same equation, okay, and place in 55. So what we can get here is this, minus 2 times, bracket 55, squared, plus 140, times 55, close bracket, and there is 1,650. So we weren't too far off at all with our guess, okay? Okay guys, always remember calculating it is more accurate than the graph, because the graph can sometimes have inaccuracies in the drawing, okay? So just make sure that if you ever ask that question, it's always solving the equation or calculating it manually. That's more effective than the graph.